record. All right, so questions. I'm going to take down the questions, but I'll do them after the lesson because the lesson's relatively short. Questions you would like me to do from whatever pages you like?
Page 231, questions 3 and 7.
3 and 7, okay.
I forget what I said before.
I think you also had 234, some of the parts of 1.
Yeah, like the ones with the like F. Well, I think F from F to J is to where I was just, yeah. That's where I was like just stopped and was confused.
Okay. We'll come back to that. Nathan, did you have any questions?
Well, Evan already said one of them, but for number 1 on page 234, does it matter which side you move over?
Nope. Not at all.
Okay. Then I would also like G, number 1G on page 234, H and M.
Okay.
And then number 7.
And 7. Okay. I'll do that. Today's notes are relatively short. Am I recording? Yes, I am. All right. So let's look at today's stuff. Okay, how do I change this? So, well, I guess if people would come to class, then the notes wouldn't be covered. That's all I can do right now. So anyway, take those down. Give me a thumbs up when you got it, please. Excuse me. Thank you, Nathan. Thank you, Evan. Sadie, you might want to take a screenshot because we're about to move on.
Sounds good. I just did.
Cool beans. Oops, that's the wrong next slide. This is the next slide. Thumbs up, please, when everybody's got that one. Thank you, Sadie. Thank you, Nathan. Thank you, Evan. All right. Let's do some examples. So, get this chat window out of the way. Something to think about for my physics people, or not physics, pre-cal. We were going to do the test on Thursday. The world has changed. Our in-class time remotely is Wednesday. Is that enough time? Think about it. We'll talk in math tomorrow. So here is the quadratic formula, quadratic equation. The discriminant is in blue. This can tell us how many solutions we have just looking at the discriminant. That's the point of this, is simplify everything to b squared minus 4ac. It'll tell us how many. It won't tell us what x equals, but it'll just tell us if there are solutions and how many and what type. So first example, page 237, numero uno, says find the value of each discriminant and describe the nature of the roots. So x squared, oops, not equals, minus x squared minus 6x minus 3. The 1 in front of the x is a, the negative 6 in front of the x is b, the negative 3 here is c. So our discriminant is b squared minus 4ac. B is negative 6, negative 6 squared minus 4 times 1, a is 1, times c, which is negative 3. So negative 6 squared is 36 minus 4 times 1 is 4. 4 times 3 is 12. It's 2 negatives, so it's plus 12. 36 plus 12 equals 48. Therefore, two distinct solutions, distinct, different, whatever word you want to use. That's all there is to it so far. This is probably going to be the simplest lesson of this unit, which is probably music to some people's ears. Are we okay with this? Does that make sense? For those of you that can't see, because of the chat window, then come live. Because anyway, feeling blah, this whole everything going remote bums me out. Any questions about this? Move on to number 2.
Sorry, how do you know it's two distinct solutions?
Because if we have 48 underneath the root sign here, it's going to be, there's a number here, plus or minus the root of 48 over something else. That plus and minus means we're going to have two
Oh
different.
yeah.
That makes sense?
Yes, for sure. Thank you.
And then, yep, no worries. And then you're going to see examples of where it doesn't work and why. Number
Okay.
2x squared plus x plus 4, 2x squared plus x plus 4. The discriminant, b squared minus 4ac. And remember, so this is a, plus 1 here is b, and plus 4 is c. So b is 1. We can all do that. 1 squared minus 4 times a, which is 2, times c, which is 4. Some of you might already see where this is going. We're going to have 1 minus a big number. We're going to have a negative number here. 1 minus 4 times 2 is 8. 8 times 4 is 32, minus 32, which equals negative 31. Give me a second to write that down. If we have a negative under the root sign, what happens? What is the root of negative 31?
Nothing.
Nothing. It's an imaginary number. There's no solutions. It's an empty set. There's all kinds of different ways to say it. So there are no solutions. We have a negative under the root sign, then that means we've hit a brick road. It's not a road, it's a wall. You can't go further. Are we okay with that? On to the question, example 3. Stop me if I'm going too fast. Staple it in here. Number 3, 9x squared minus 6x plus 1, a, b, c. B squared minus 4ac, that's our discriminant. The b is negative 6, minus 4 times a is 9, times c, which is 1. So this is 36 minus 4 times 9, 36, which equals 0. Therefore, we have 1 double root. And if you're wondering, maybe you forgot kind of what a double root, if we have, so this is positive. So wherever this is, I don't know that it's over here. I'm just making an example here. The vertex is right on the x-axis. So when you've got this factored, it'll be like x minus 5 or something like this squared. And then, there might be a number for a and plus, no, there won't be anything here. This would be 0 plus 0. So basically x minus 5 squared is like x minus 5 times x minus 5. That's why it's called the double root. You're going to get one answer because we won't have the plus or minus in front of the root sign because this is just 0. So the plus or minus goes away. You're going to have negative b over 2a. So in this case, it'd be negative b. So it'd be positive 6 over 2a. So 18, 6 over 18 would be 1/3. So it would actually be at 1/3 where the vertex would be, and it's squared. That's why it's called the double root. Does that make sense? Are we okay? So you've seen the 3 kind of possibilities in the first 3 examples. There's 2 more examples, and they're just to make things a little grosser, just to make it a bit more challenging. Otherwise, they're the same. 2x squared minus root 3x, so that's our b, which clearly is kind of ugly, minus 5 equals 0. So the discriminant, b squared minus 4ac, we make our substitutions. B is negative root 3 squared minus 4 times a, which is 2, times c, which is negative 5, which makes this positive. Root of 3 times the root of 3 is 3 plus, because we have 2 negatives, 4 times 2 is 8, 8 times 5 is 40. 2 distinct real roots, answers, solutions, however you want to refer to it. This feels a little blurry, it bothers me. That's better. We okay with that? Ready for one more example? Two x minus 1/3 x squared equals 6. So firstly, it isn't giving it to us in the a squared plus bx plus c format, so we have to change that. Two ways we can do this. See how that's a negative in front of our x squared, so we can move it to this side so our leading coefficient is positive. Or we can bring it over here. It doesn't matter. It honestly works out the same. Myself, I prefer that to be positive. So I'll do it this way. 0 equals 1/3 x squared minus 2x plus 6. For those that are interested, feel free to try it the other way and you'll see it'll work out the same because the signs will change, and it's just one of the wonderful things about math. Discriminant b squared minus 4ac. So b is one, no it isn't, it's -2. -2 squared minus 4 times a is 1/3. And times c, which is 6. That'll help with our 1/3. -2 times -2 is 4 minus 4 times 6 is 24. 24 divided by 3 is 8. Well, looks like it's negative anyway. -4, no solutions. And you'd still get no solutions if you put all this onto the left side instead. So this was a negative and this was a negative. It would still work out. Questions? And just a real quick way to see it, without actually doing it. Notice the b is -2. It gets squared, so it doesn't matter what the b is. So 2, if it were positive, if everything were on the left side, it wouldn't matter. Now here, the negative's already there. A and c are positive. And the way we did it here, A and C are positive. If it was on the other side, they would both be negative. If they're both negative, 3 negatives will still make it negative. So it doesn't matter which side of the equal sign you go on, it'll still work out the same way. That's all I got for new material. Any questions about that? I'm going to start going over questions from previous work. Okay, we're good? All right. Get rid of that. Okay, page 231, number 3. Hate this question. Just kidding. I have no idea what question it is. Page 231, number 3. Okay. Page 231, number 3 says 2x squared equals 8x. 2x squared equals 8x minus 5. Solve the following quadratic equations by completing the square. All right, so we got to complete the square here. So I'm just going to bring the 8x over. I'm going to leave the -5. So it's 2x squared minus 8x equals -5. Factor 2 out. 2 times x squared minus 4x equals -5. Now I'm going to add to this so I can move towards completing the square. X squared minus 4x. 4 divided by 2 is 2. 2 squared is 4. So I've added 8. So I've added 8 on this side. I need to add 8 on that side. If I was keeping everything on this side, I would add 8 here, and then outside the brackets, I would put -8. So now I'm going to complete the square. 2 times x minus 2 squared equals 3. Stop me if I'm going too fast. I'll slow down here because this is where it gets a bit trickier. I'm going to divide both sides by 2. X minus 2 squared equals 3 over 2. Now I have to root both sides. So it's x minus 2, drop the square, equals plus or minus the root of 3 over 2. X equals, I'm going to add 2 to both sides, 2 plus or minus the root of 3 over 2. Now, something important to remember, we cannot leave this 3 over 2. Root of 3 over 2 is the same as saying root of 3 over root of 2. Now remember, it's been a while, but we cannot have a radical in the denominator. So we have to multiply it by root 2 over root 2. So this becomes root 6 over 2. So this is 2 plus or minus root 6 over 2. So you want your full answer, x equals 2 plus root 6 over 2, comma 2 minus root 6 over 2. Any questions about that?
Would it be okay if you divide by 2 earlier?
Yep.
Okay.
Yep. Like what you could do if you wanted is right here you could divide by 2. You know what I mean?
Yeah, that's what I was doing.
Yeah, and that's fine because you got the same answer, right?
Yeah.
Yep. As long as you follow the rules of math, it'll work out. All right, Evan, you're good with that?
Yeah, that's good.
Okay, so let's go to see if I can fit it on this page. Number 7, right? Yeah. Number 7, the question is 8x squared plus 2x minus 3 equals 0? Yeah, equals 0. All right. I'm wondering if I should do it your way, Nathan, just to show. No, I think I've been doing it this way. I don't want to change anything right now. So 8, factor of the 8, so it's x squared plus 1/4 x. Is that right? Because 8 times a quarter would be 2, yeah. And then we have this -3. I'm going to put that on the other side. So I'm going to add 3 to both sides. So I did 2 things at once here. Took the 8 out of these 2 things, and I moved this guy over. Right here, you could divide by the 8 if you want. It's up to you. 8 times x squared plus 1/4x. 1/4 divided by 2 is 1/8. 1/8 squared is 1/64. So I've added 8/64, which is 1/8. So I have to add up to both sides. So now it's 8x plus 1/8 squared equals, if I put this over 8, 3 times 8 is 24, so it's 24/8 plus 1/8 equals 25/8. So this is kind of our mid step. We don't really need that anymore. Now divide both sides by 8, which means I'm going to multiply the bottom by 8. So it's x plus 1/8 squared equals 25/64. When you divide a fraction by a whole number, you're multiplying by the reciprocal. Just remember, what was this? 25/8 divided by 8 is like saying divided by 8/1. So you flip and multiply. That's why we got 25/1 or over 64, 164. Settle down. Take the root. X plus 1/8 equals plus or minus the root of 5/64. 25/64. Well, thankfully, this is 5/8 plus or minus 5/8. So x equals plus or minus 5/8 minus 1/8. So our answers, so if it's positive 5/8 minus 1/8, 5 minus 1 is 4, 4/8 is a half. So x equals a half. Or if it's negative, then it'll be -6/8, which is -3/4.
At the beginning, why did you take the 8 out instead of the 2?
I have to take out the number that's in front of the x squared. That,
Okay, sounds good.
that x squared, I want it to just to have 1 that we're dealing with. If I just took out the 2, then we'd be left with a 4 here. So it doesn't matter. And sometimes you're going to get questions, not from me on the tests, not now. But like this could be an 8, this could be a 7, this could be 11. So you've got some ugly fractions, but I'm not going to do that to you. The world is stressful enough right now. Evan, you good? This was your question.
Yeah, that's good. I was just confused about like you had to have like 2x in front, like you had to factor out the
Right.
8.
Yeah, it's gross. Like, yeah, you get messy with the fractions. Like I said, this one thankfully was at least kind of an even fraction, but yeah, sometimes you'll get like 4/3 or 6/13 or something, but yeah. All right, moving along. page, what are we, 234. Lots of parts of 1. First one is A, B, C, D, E, F, 234, F. All right. Okay, so when we're dealing with fractions, there's lots of different ways of dealing with it. So 2 plus x over 3 equals 3x squared over 2. So there's a bunch of different things that we can do, because the first thing that I want to do is I just want to get rid of the fractions. It's a pain. The simple way, if you guys remember this, if I multiply both sides by 3, the 3 on this side cancels. So it's just like I get rid of it. So really, I'm kind of just multiplying this side by 3. And this, I'm doing the same thing on this side. I multiply this side by 2. Another way of looking at it, a common denominator, 2 times 3 is 6. So I can multiply everything by 6, and it'll still work out the same way. This is the easiest way. 2 times 2 plus x is 4 plus 2x. 3 times 3x squared is 9x squared. Did I lose anybody? And this is the same way the simplified version would be as if you multiplied everything through by 6. 6 times 3 is 18. 18 divided by 2 is 9. 6 times 2 is 12. 12 divided by 3 is 4. 6x divided by 3 is 2x. And so now we just go from here. Well, I don't even know what the question's asking here. Express each equation in standard form and then give, oh, okay. So here, you could move this, this 9 over here, and so it's negative. I like it positive. So 0 equals 9x squared minus 2x minus 4. A equals 9. Looks like 9 equals 9. A equals 9. B equals negative 2. Those signs matter. C equals negative 4. Now, if you did it the other way, so this is negative and these two are positive, totally okay. Totally 100% okay. But it has to be just those two combinations. It's not like plus or minus, plus or minus, plus or minus. It's either this or negative 9, positive 2, positive 4. Cool, cool, cool. Hearing nothing, I'm going to continue to G. The root 2 of x squared. Root 2 of x squared. Notice the root is just over the 2 plus 7 equals 2 minus 3x. Okay, as ugly as it is, we just got to move everything over. So it's all on one side. So root 2x squared plus 3x, subtract 2 from both sides, be plus 5 equals 0. A equals root 2, B equals 3, C equals 5. Again, you could have the opposite signs for each of these as long as it's consistent. Is that right? Yeah. When we're getting rid of fractions, I said you can multiply by a common denominator, multiply by 6, everything divides. A lot of people don't like these root signs. I'm one of them. I wish it wasn't there. There's no easy way to get rid of it. If you multiply everything by root 2, it's gone from here, but now it's attached to everything else. So thoughts, comments, questions? A, B, C, D, E, F, G. I'm going to do H. More fractions. So now H is not as simple to deal with fraction-wise as this, but it's really not a big deal. H says 1/3 x squared plus 2 equals x minus 1 over 3. I'm going to multiply everything by 3. I'm going to multiply everything by 3 because whatever you do to one side, you do to the other, and that all will work out. So 3 times 1/3 is 1. So it's x squared plus 3 times 2 is 6. These 3's cancel, right? This is like 3 over 1 times x minus 1 over 3. They cancel, so it's just x minus 1. Bring everything over. X squared. And I'm getting texts from, yeah. X squared minus x plus 7 equals 0. A equals 1, B equals -1, C equals 7. Or, I'm not going to keep writing this, just last time. -1, +1, -7. Any questions? Am I going too fast? Evan, how you doing with these fractions?
It's okay now that you're explaining it.
Okay, do you want me to do J, the last one? It's kind of the hardest one.
Sure.
Okay,
Can you do I as well?
sure. Well, let me do I first, because in order, and then Evan, if you want me to do J, I'll do it. So I, is that a 1 or an L? It's a 1. So it's 1 over R plus 4 over R plus 5 equals 3. Okay, so this is good old-fashioned fraction work. Remember with this one, 3 and 2, I said common denominator would be 6. I just multiplied 3 times 2. Well, that's what we can do here. We can say that the LCD equals R times R plus 5. I don't need to multiply them together just yet. I can just leave it like that. And if I multiply everything by R times R plus 5, it'll make things simpler. So 1, I don't even really need to write the 1. R times R plus 5 over R plus 4 times R plus 5 over R plus 5 equals 3 times R plus 5. Now I need to simplify everything. R's cancel here. I got R plus 5. R plus 5's cancel here, so I got 4R. And then here, I have to multiply these through. I just want to go back to here for 1 second. If there was like a plus, like it was 4R plus R plus 5 or something, I couldn't cancel it. Only when everything on top is multiplying. Essentially, the R plus 5 is common to everything on top, and then it can be canceled. Here, 3 times R is 3R, 3R times R is 3R squared. And then 3R times 5 would be 15R. I've got my R squared on the right, and it's positive, so I'm going to leave it there. So I'm going to make this 0 equals 3R squared. And now I've got 15R minus 5R. This is going to be -R, -4R. So it's going to be plus 10R minus 5. A equals 3. I don't know how to write 3's anymore. A equals 3, B equals 10, C equals -5. Again, could be negative, negative, positive. And if you doubt that, because it seems weird, you could punch this into Desmos and then punch it with everything with an opposite sign. It'll give you the same zeros, and that's what we're looking for. Do you want me to do J? Or first of all, are you okay with this, Nathan?
Yeah, that's good.
Do you want me to do J, Evan? Or do you want to try it?
Sure. Yeah, sure.
Yeah, sure. To you trying it or to me doing it?
To you doing it.
Okay. Okay. Where's the top of the page? All right, J. Page 234, 1J says -10 over 3x minus 2 plus 2x equals 5. So our LCD here is 3x minus 2. I'm just going to multiply everything by 3x minus 2 to get rid of the fractions. So -10 times 3x minus 2 over 3x minus 2, those are going to cancel, plus 2x times 3x minus 2 equals 5 times 3x minus 2. Now I just have to simplify. So it's -10 plus 6x squared minus 4x. 2x minus 2 is 4x. 5 times 3x is 15x minus 10. And then we just simplify. My leading coefficient is positive and it's on the left, so I'm going to leave it over here. 6x squared, so minus 4x and minus 15x will be minus 19x. Got this, I got this, I got this. -10, those guys are going to cancel. A equals 6, B equals -19, C equals 0. Because there is no C there. You could write it out plus 0 if you wanted, but It's like me saying I am 47 plus 0 years old. It's redundant. Good with that?
Yeah.
Anybody else questions on that before we jump ahead somewhere? What am I doing next? Am I doing 2M?
I actually asked for one, but I meant 2G, H, and M.
Okay. Let's look at that. 2G. A, B, C, D, E, F, G. Use the quadratic formula to solve each of the following quadratic equations in cases where the roots are irrational numbers. Round your answer to 2 decimal places. All right. 2G says 2x minus 3 over 5 plus x squared equals 2. I'm going to first get rid of that fraction, multiplying everything by 5. It's going to cancel here. So it's 2x minus 3 plus 5x squared equals 10. That's multiplying everything by 5. I'm going to subtract 10 from both sides and then reorder this. So it's 5x squared plus 2x minus 13. It's our A, it's our B, it's our C. And this is quadratic formula, right?
Yeah, that's all I needed.
Oh, you're good there?
Yeah.
Okay, A, B, C, D, F, G, H. G, H, so M squared plus the root of 29M. Root of 29, what a number, plus 5 equals 0. Okay, so this is negative B plus or minus. It's already in our correct standard form, so we just need to figure out the A, the B, and the C. Negative B plus or minus the root of B squared minus 4AC all over 2A. That's what X can equal. Negative B, so it's negative root 29. Wow, this could be gross, eh? Negative root 29 plus or minus the root of B squared, so that's just going to be 29. B squared minus 4 times A, which is 1, times C, which is 5. All over 2 times 1, which is all over 2. What a gross looking number this is. So it's negative root 29. Negatives on the outside, so that's okay. Plus or minus, we simplify what's inside. 29 minus 20, so it's going to be root of 9. Well, that's going to give us a nice number all over 2. So it's negative 29 plus 3 over 2. Actually, I'll just say plus or minus 3 over 2, which is going to be, okay, so negative 29 plus 3 would be negative 26. Negative 26 over 2. Or negative 32 over 2. We simplify these. 26 over 2 is 13, so it's negative 13 or negative 16.
How did you get rid of the root 29?
Oh my goodness, it should still be there. I goofed. It should still be there. Sorry. I don't know why. I guess I saw this drop and my brain said drop that. So yeah, so it's ugly answer. I was thinking at the end, wow, that worked out way nicer than anticipated. So it's negative root 29 plus 3 over 2 or negative root 29 minus 3 over 2. Yeah, that's better. Sorry, good eye. Oops. And these are ugly answers, but that's just the way she works sometimes. Oh, back of the book is asking for a decimal, right? So then you just punch this into your calculator. Does that make sense?
Yeah.
So on a test, this would be your final answer because you're not getting a calculator. You're good with that, Nathan?
Yeah, that's good.
And G, what else did you want from this? H? Oh no,
M.
that was H. M on the next page. Okay. Get rid of some fractions first. Now, the thing is, too, it's worth mentioning, you don't have to get rid of the fractions, but it's so much easier. 2 plus 7 over r equals 4 over r squared. Actually, I don't know how you would do it if you didn't. So I'm going to multiply everything by r squared. Because r squared, r is common to r squared, so that'll cover it. It's like saying if this was 2 and this was 4, I just multiply everything by 4. I don't need to multiply everything by r cubed or anything. So 2r squared plus 7r squared over r equals 4r squared over r squared. Then we look to simplify it. R squared cancels with the r. These r squareds cancel, so it's 2r squared plus 7r equals 4. Bring the 4 over, 2r squared plus 7r minus 4 equals 0.
Yeah, that's good.
It's our A, it's our B, it's our C. If you're good with that, then it was number 7. Is that right?
Yeah, that was the other one.
Anybody else before we jump to number 7, page 235? Are we okay with this? So I should leave it there if I'm going to ask you. Okay, let me just get a drink of water here. My Gatorade club soda. M. For the following questions, find the answers to decimal. A triangle has an area of 80 centimeters. So area equals 80 is number 7, by the way. If its base is 2 centimeters longer than twice its height, how long is the base? Okay, so area equals 80, which means that 80 equals base times height divided by 2. We know that if the base is 2 centimeters longer than twice the height, so 2h plus 2 equals b. 2h plus 2 equals b. Is that right? So the base is 2 centimeters longer than twice the height. Okay, and so this is, once we have these two, we're off to the races, because I can just punch it up into here. So b, what I have for b, I can put this in up here. So I'm going to rewrite this equation. 80 equals 2h plus 2 times h all over 2. And then I just simplify it. I'm going to multiply everything by 2, or I'm essentially moving it over here. So it's 160 equals, and then simplify this, 2h squared plus 2h. I'm going to move the 160 over here. 0 equals 2h squared plus 2h. Minus 160. For what it's worth, it won't make any difference with your answer, but I can divide everything by 2, and I can make this h squared plus h minus 80. You don't need to, probably makes things just a little bit easier. It's important to know, like when I go from here to here, you might be thinking, well, there's a 0 here. What does it matter? Well, 0 divided by 2 is 0. I could have done it over here when there were no zeros. Divide one side by 2, divide this side by 2. So this just makes it simpler. And this is quadratic formula, right? Yeah, so x equals negative b plus or minus the root of b squared minus 4ac all over 2a. Negative b, so negative 1. That's important, there's a 1 there. Negative 1, that seems so insignificant, but that's not a 0. Negative b plus or minus the root of b squared, so it's 1 squared, which is 1, minus 4 times a, which is 1, times c, which is negative 80. Now notice this is easier than throwing the 2's and the 160s in there. It's not a huge difference, but it matters. 2 times 1 is 2. Now we simplify. So we have negative 1 plus or minus the root of 1 plus, because we have the 2 negatives, 4 times 80, it's 160 is 320 plus 320. So it's the root of 321 over 2 equals 1 plus the root of 321 over 2 and 1 minus the root of 321 over 2. I don't imagine 321 is a square, but I'm just going to check. Yeah. So this would be good on the test. You can punch these into the calculator to see what the back of the book says.
So that would be the length of the base?
So this, we just solved what h equals.
Okay.
So
then we have to multiply that by 2 and then add 2.
Yeah, to get the base. Yeah, exactly.
Okay.
Yeah, because we made it in terms of h. It could have been in terms of B, if you just isolated the B, which would be harder, so it'd be weird to do that. But and then you just resubstitute it back in. You okay with that?
Yeah.
Anybody else? Questions about anything else?
How is the test gonna work?
Yeah. Yeah. I was thinking about kind of talking about it here, but there's only 3 of you. Well, maybe I should just let you 3 are here, and so you 3 should be the ones that make the call. But I'll talk with you guys in class tomorrow. Tomorrow's kind of a study period, because what we were going to do is we're going to have study period tomorrow and Wednesday, and then test Thursday. Well, the way the schedule is going to be with remote learning, and forget about how we're even doing the test, just pause that for 1 second. With remote learning, our pre-cal classes are Monday and Wednesday. Our physics classes are Tuesday and Thursday. So tomorrow we'll talk, because that would mean that really the test would be moved from Thursday to Wednesday, which I don't like doing that to you guys. I don't want to spring that on you. Thursday is not supposed to be kind of a real kind of contact class. So it might mean the test is next week. Once we figure that out, which is fine, like it just is what it is. Just is what it is. But once we figure that out, is how we're going to do it. And in all honesty, my gut is to just send everybody the test. Let's go with the honor system. Teachers can tell if something's fishy, if there's some funny business going on. But so you do the test, you take pictures of it, send it back to me, and that's kind of how we'll do it. That's me thinking out loud right now. I do want to bounce it off the group, see if anybody's got things I haven't thought of or what have you. But you have any thoughts about that? Gut reaction to that?
Is tomorrow an in-school day, even though
Yes.
it's switched to remote learning?
Yes, tomorrow's in school. Wednesday is not.
And then Thursday would be at home as well.
And then we don't see each other in person till June, if we do. Like cases were skyrocketing yesterday, the last couple of days. I would imagine numbers are probably going to plateau maybe, or keep going up, and then see how much they come down over the next 3 weeks. We may not see each other again this year, which means ever, because some of us are moving on. So it's a mess. It's a mess. I hate it. But welcome to everybody else. Does that answer your question?
Yeah.
Long answer to a simple question. But yeah, Monday and Tuesday are in school, and everything else is remote. And there's going to be a email going home, I think today or tomorrow, to specific to grade levels, saying this is what the schedule is going to be. I'll wait to make sure it's finalized before I share it with you guys, but I'm pretty sure Monday, Wednesday is pre-cal, Tuesday, Thursday is physics. And then the alternate days, there's going to be kind of office hours times, if you guys have questions, want to meet or whatever online, but it's 2 lessons per week. And so this is why I was talking about, like, physics will really slow down. Pre-cal will have kind of what we have to do, but I'm going to steadily kind of go through the rest of the book, the things that I think are important for next year. So at least you can be aware of that. I won't require you to even watch them or anything like that. But at least you can kind of be aware of for next year, to make it a little bit easier transition. None of the teachers are going to be crazy, say, well, it doesn't matter if you didn't get to it. This is what you need. Nobody's going to be like that, but it'll just help. I think it'll help. So thoughts, questions, anything else before we go? If not, I'm going to stop recording, and then I want to talk to you privately for a second there, Nathan, if that's all right with you. It's nothing bad.